When everything is exotic and strange, the familiar beckons. And when it comes to exploring the solar system, the familiar calls us to Mars. Although it is clearly an alien world, Mars is also a planet with landforms we immediately recognize. It is a world with deserts and dunes, cliffs and canyons, a landscape we can imagine ourselves exploring firsthand, on 2 feet or on 6 wheels. But familiarity doesn't make Mars any easier to understand. After scrutinizing its landforms from orbit and sampling its soil and rocks from the surface, we have become better acquainted with Mars than any other planet in the solar system apart from our own. But our questions about its present state and complex history have only multiplied, including the biggest question of all: did life ever exist here? Mars is not like Earth, where life is abundant and obvious. It's also not like the Moon, where there's really no chance for life at all. Mars is somewhere in between, and so it can help us define where life can and cannot exist. When we journey to Mars, we journey to the borderland. Mars's borderland status is nothing new. Astronomers have been musing about the potential for life on the red planet for more than a century. When the first grainy close-ups of Mars were radioed back in 1965, scientists were surprised and a little disappointed. The images showed a barren and cratered surface, much more like the Moon than any place on Earth. Apparently, the red planet was the dead planet, and any notion of spotting life on the surface, even primitive life, all but vaporized. But first impressions can be deceiving. As follow-up missions arrived in the late 60s and 70s with increasingly better cameras, it became clear Mars is a far more interesting and diverse planet than anyone had realized. Yes, there were impact craters, but there were also signs of a colossal geologic history. Giant volcanoes, larger than any on Earth, were found towering over the Martian plains. The largest of all, Olympus Mons, rises to a height of 24 kilometers from its base, 3 times higher than Mount Everest, making this not just the tallest peak on Mars, but the tallest in the solar system. Such an impressive structure must have arisen through widespread eruptions of lava that poured out across the surface again and again, possibly over billions of years. Olympus Mons sits atop a giant bulge known as Tharsis that protrudes from Mars and makes it a distinctly lopsided planet. Ultimately, it led to a spectacular splitting of the planet's crust, and the Valles Marineris stagger the imagination. It is more than 10 times longer than Earth's Grand Canyon, and 4 times as deep. Today, the best images of Mars come from the Mars Reconnaissance Orbiter, an orbiting spacecraft that carries the most powerful telescope ever sent to another world. Capable of resolving details on the surface as small as a dinner plate, it has given us an unprecedented look at Mars in all its splendor. From exquisite sand dunes to tracks left behind by Martian dust devils. But perhaps the most interesting views are the ones that suggest water once flowed on Mars. Deep inside Valles Marineris, it appears as if there were layers of sediment deposited in shallow Martian lakes, long before the giant canyon formed. Even the shape and orientation of the terrain suggests water once flowed on Mars. These hints of a watery past grow much stronger as we cast our view beyond Valles Marineris to a series of large but empty channels leading away from the Tharsis Bulge toward the low-lying regions further north. Although they dried up long ago, these valleys must have been created by vast outflows of moving water that cut across the Martian landscape, spilling out into the northern plains.
I'll never slow up, no I don't take shit. I got no love for the fakeness. If you wanna play
In
tough,
some
I wanna
cases,
hate
these
this.
channels
I'll
measure
show
100 kilometers across.
I don't ever
And
slow
far
up,
away
no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it. I got facts over tracks, this and that, spitting slow, spitting fast, I can roast, I can gas, think I'm okay at last, but I don't know if that can erase all the past and the pettiness, a reflection of the emptiness, hilarious, you think you're with my time, you're delirious, mysterious, because you hide behind a fake exterior, inferior, you know I'll always be a bit superior, get off of me, this ain't no humble brag, I want you to hear words, you can say them back, I want you to feel free from the chains that last, and to believe in what you got, it was built to last, yeah.
Visible today.
Now that I've been put through hell, I never got anyone's help. I had to do it all myself.
Other signs that water may have flowed.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
Gonna learn the consequence of being incompetent. Mental health is confidence, dreams into modestness. I'm not here to save the day, that's for you to take away. I could play a million mind games, but instead of say something not illogical, something that is topical. Rub it on and let you go, make yourself unstoppable. Dreams are irresponsible, but they're always possible. If you just believe, you could be so remarkable.
Thoughts in my head, a collage and they spread. I'll be great one day, going off of my meds. No, I'm not giving up, no, I'm not giving in. I will make it to the top, taking off in the wind. I gotta make it, I'm saving every day to taste it. I'm patient, but my mind, it can hardly take it. I'm chasing a dream that I've had for several ages. A vacant, modern kingdom for the taking.
Rounded look.
Now that I've been put through hell, I never got anyone's help. I had to do it all myself.
One of the most exciting.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
So small, they must be recent. Otherwise, the steady deposit of wind-blown dust would have obscured them. Could there really be liquid water periodically bubbling to the surface on Mars? If so, the implications for life are enormous. After more than 4 decades of concentrated exploration, there's no doubt that Mars has a rich history, which certainly included liquid water and may have once included life. Furthermore, there are hints that Mars continues to be an active planet today. It is not yet a dead world, at least in the geologic sense. It is still a borderland. All of this is impetus to explore Mars further. But there are limits to what can be seen and sensed from space. To answer the question of whether Mars is a living world, we must touch, taste, and smell it. These goals can only be achieved by taking our explorations down to the very surface of Mars. Five, four, three, two, one. We have ignition and liftoff. Like the great voyages of discovery centuries ago, the journey to another world is fraught with danger. Atmospheric entry on my mark. And when it comes to landing on Mars, 5, 4, 3, 2, 1, mark. It is always the final moments. Phoenix now 2 minutes and 25 seconds past the entry point. When the peril is great. 80 meters. 50 meters. Come on. Scott lost space detected. Altitude 40 meters. 30 meters. 27 meters. 20 meters. 50 meters. Standing by for touchdown. Touchdown signal detected. Landing sequence initiated. It is hard enough to design a machine that can land itself on Earth. But to do it on another planet, where humans have never set foot, where knowledge of changing conditions is scarce at best, to have no margin for error between a safe landing and total catastrophe, and to do it in a place that is so distant, even a simple call for help would take several minutes to reach Earth, that is a challenge indeed. But that is precisely what must be done to touch another world. So far, 6 landers have set down safely on Martian soil, and they have transformed our understanding of the planet as only first-hand experience can. Scientifically, these missions were designed to discover the geologic history of Mars, but they also carry a powerful implication about the future. It's not just the ancient past we seek when we land our probes on Mars, but a new dawn in space exploration. A red dawn. In 1976, 2 NASA spacecraft named Viking 1 and 2 became the first to establish a beachhead on Mars. And the view was electrifying. Geologists were immediately reminded of deserts they had visited on Earth. Once the Viking landers set to work, the similarities began to fade. While the results did not completely rule out life on Mars, they suggested that any life that managed to survive here would need to be sheltered underground or in some other impossible-to-reach location. It would be more than 20 years before another successful attempt was made to land on Mars. In 1997, NASA's Mars Pathfinder landed at the mouth of the Ars Valley, a vast channel that looks like it was carved by running water. The landing site was surrounded by broken and tumbled rock. Boulders were slanted in a downstream direction. All signs of an ancient and violent flood. The star attraction of the mission was a small rover that rolled off the lander and trundled up to nearby rocks to analyze their compositions. It was a vivid demonstration of what was needed to really begin tackling the mystery of Mars. A set of wheels. In early 2004, two rovers named Spirit and Opportunity landed safely on opposite sides of Mars. Each embarked on its own motorized trek across the red planet's surface. From the start, it was obvious that the two rovers had landed in very different settings. Spirit had been sent to Gusev Crater. Evidence from orbit suggested it was an ancient lake where standing water may have left its mark in the soil chemistry. But when Spirit opened its electronic eyes, it found a barren plain littered with volcanic rock. Meanwhile, Opportunity scored an early triumph. It was sent to Meridiani Planum, where remote sensing had spotted hematite, an iron-rich mineral that on Earth is often associated with water. Meridiani turned out to be a flat, nearly featureless plain, but miraculously, Opportunity landed in a small crater with an exposed rock outcrop. For the first time, scientists would be able to sample rock on Mars in the place where it formed. What Opportunity found, after wheeling up to the outcrop, exceeded everyone's wildest expectations. The rock was layered and contained ample evidence that it formed in a watery environment. It also contained hematite in the form of tiny spheres, nicknamed blueberries, which grew by precipitating out of water and were later exposed as the rock weathered away. But the best was yet to come. Back on Gusev Crater, after investigating the terrain near the landing site, scientists sent Spirit rolling towards a set of distant hills nearly 4 kilometers away. It would take 3 months to reach the hills and many more to climb them. But eventually, Spirit reached the top and radioed back a sweeping panorama. In the years that followed, Spirit descended to the other side of the hills, surviving 3 Martian winters and eventually discovering home plate, the remains of a volcanic vent where hot rock once made explosive contact with water. Things were also going well at Meridiani. Once Opportunity set out across the plains, it discovered an even larger rock outcrop, acidic water. While at other times there was no water there at all. After nearly 2 years more of roving, Opportunity arrived at the edge of Victoria Crater and recorded one of the most spectacular vistas in the history of Mars exploration. High overhead, the newly arrived Mars Reconnaissance Orbiter was there to record the moment from space, spying the tiny rover perched at the crater's rim. The journey of the Mars rovers has been a scientific adventure unlike any so far in our exploration of the Red Planet. Rather than showing us Mars in an isolated spot for a brief window of time, they have shown us Mars over many years and many kilometers, including places where water once flowed. Next, scientists wanted to know about the state of water on Mars today. Compared to the Mars rovers, the Phoenix lander was a modest mission, but with an ambitious goal: to become the first spacecraft to touch water on Mars. Scientists expected to find that water locked in a frozen state just below the surface of Mars's polar regions. Here, the landscape is dominated by low mounds with trough-like boundaries. These mounds are caused by the expansion of ground ice, forcing the soil upward. After a bit of digging with its robot arm, Phoenix exposed something white just centimeters below the surface. It was ice, the first direct link to a watery past on Mars. Phoenix landed in the low-lying northern plains of Mars, an area that may once have been a Martian ocean. Although Phoenix could not confirm this, it found the soil here is alkaline, similar to what might be found in seawater on Earth. What we've learned from all these missions is that Mars was a water world, and still is today, although that water is hidden from view. As for what that means for life on Mars, that's a question for future missions. But in a sense, all of these missions are already paving the way for life on Mars, human life. The landers and rovers we build could be the leading edge of a new wave of exploration that might one day take astronauts to the Red Planet. If so, the human story on Mars has already dawned. Different planets on vastly different tracks. This fundamental truth begins with the sun, a giant blazing ball of hydrogen gas. The sun keeps shining because it's swirled around the infant sun. In the beginning, most of that matter was in a gaseous state. But near the sun, it was too hot for gravity to hold on to the gas. So the planets that formed in the inner solar system were small and rocky. In the outer reaches of the solar system, it was always cold enough for gas molecules to stick together and form ice. Billions of years ago, that ice gathered into bigger and bigger chunks until gravity took over, pulling in vast quantities of material and setting the stage for planet making on a giant scale. Here's what happens when you get enough gas together to make a planet. Jupiter is the colossus of our solar system. Beneath its swirling clouds, there's enough room to fit 1,000 Earths. Jupiter is big, too big to be hidden beneath Jupiter's turbulent clouds. Because Jupiter is liquid, it can spin on its axis at high speed, much faster than Earth. One day on this mammoth world lasts only 10.5 hours. This fast spin generates high-speed winds in Jupiter's atmosphere, giving the planet a striped appearance. Somehow, Jupiter's rotation also powers the Great Red Spot. A giant, swirling storm, larger than the entire Earth, that has been raging as long as astronomers have had telescopes to watch. The spot has a deep structure that penetrates many tens of kilometers, like an open window into Jupiter's atmosphere. Jupiter's visible cloud tops are made of ammonia, but scientists have not yet discovered what chemical pigment gives the Great Red Spot its distinctive color. Other storms come and go on Jupiter. This unique view, made of many separate images, shows the atmosphere of Jupiter as it would appear from somewhere above its south pole. Over time, the spots move and sometimes collide like giant ships on a stormy sea. But none have lasted as long as the Great Red Spot. The poles of Jupiter are also where we find intense aurora caused by solar particles trapped in Jupiter's powerful magnetic field. Like giant-sized versions of the northern lights on Earth, they glow brightly in ultraviolet light. Jupiter is bigger than all of the other planets combined, and more dynamic. And for this reason, it is mesmerizing to watch. But there is another place in the solar system where gravity has outdone itself in creating a spectacle of stunning and otherworldly beauty. Centuries ago, astronomers were enchanted by the discovery that Saturn, the most distant planet that was known to the ancients, is encircled by what appears to be a set of narrowly divided rings. And as telescopes grew in power, so did the grace and grandeur of Saturn's rings. As these views from the Hubble Space Telescope reveal, the rings may start out at a wide angle, but eventually narrow to a thin plane, almost disappearing when the planet's equator lines up with Earth. It is because of observations like this that we know the rings of Saturn cannot be as solid as they look. A solid ring would quickly become unstable and collide with the planet. Instead, the rings must be made of trillions of icy particles, ranging in size from snowflakes to giant boulders, all guided by the gravity of Saturn and its moons. In 2004, scientists were given their best chance to learn the secrets of Saturn's rings when the Cassini spacecraft made a close pass of the rings before putting itself in orbit around the planet. As Cassini raced by, scientists trained its cameras across the ring plane, capturing one snapshot after another of the detailed patterns within the rings. These wave-like ripples are caused by the gravity of Saturn's many moons, which act on the ring particles to create shifting patterns of density, while opening up gaps which are kept free of material. and keep them on their narrow track. Among the strangest phenomena Cassini has witnessed in Saturn's rings are these fleeting dark spokes that seem to race around the rings much faster than the ring particles themselves. They are made of fine grains of dust, probably electrically charged and swept up in the motion of Saturn's magnetic field. Saturn is alive with electromagnetic energy, and like Jupiter, its poles are ringed with bright, dancing aurora. But in other respects, Saturn's polar regions look very different than Jupiter's. Here, Cassini gives us our best view yet of a strange hexagon centered on the planet's south pole. The hexagon is made of clouds and shaped by fierce winds, but the origin of its unique geometry remains a mystery. Cassini has revealed Saturn so beautifully that it is now one of the best imaged planets in our solar system, despite its great distance from Earth. Yet with each new image, Saturn continues to surprise and amaze us. This remarkable image shows us Saturn eclipsing the Sun, a view we cannot see from Earth. It is a heavenly image, even a poetic one, made even more touching by one other tiny detail. Buried in the rings, far off in the background, is a small bluish speck. Not a faint star, but a planet. It's Earth. How small we are in the solar system, but how great our reach as we send our cameras far and wide to bring us news from the lords of gravity, our solar system's largest planets. Saturn. To the ancient astronomers, it was the end of the line, the last stop before the stars. It turns out Saturn is merely the farthest planet the human eye can see. It's far, but it's not where the solar system ends. Once the telescope was invented, we discovered there was a lot more to our solar system than meets the eye. There's Uranus, Neptune, and the weird case of a planet that's not really a planet, Pluto. But even through the most powerful telescopes, these worlds remained remote and mysterious. To probe the solar system's real outer limits, you need a spacecraft. In 1977, Voyager 2 began an epic journey that would make space history. To date, it is the only spacecraft to visit planets beyond Saturn, starting with Uranus in 1986. Uranus's most obvious feature is its striking aquamarine color. This is the result of a methane atmosphere. Methane absorbs light from the red part of the spectrum, while blue light is reflected back into space. But while Uranus is unlike any planet closer to the Sun, it is not unique in the solar system. After traveling onward 3 times farther from the Sun than Saturn, Voyager 2 finally reached what is now the farthest known planet, Neptune. As with Uranus, it found a blue world, but one with an atmosphere that seemed more active, with bright white clouds made of ice crystals and dark oval storms. Compared to Jupiter, Uranus and Neptune are small, not nearly large enough to be big balls of liquid hydrogen and helium. On the other hand, they are still far larger than Earth, too large to be solid, rocky planets like our own. So Uranus and Neptune are fluid worlds, but they are mainly made of gases that freeze at low temperature, including water, methane, and ammonia. For this reason, they are called ice giants. Although you don't see any ice when you look at these planets, they must have formed from countless icy fragments that once filled the outer reaches of the solar system. Like Saturn, both Uranus and Neptune are encircled by rings, but their rings are narrow and dark. So dark, in fact, they resemble the color of charcoal and must be rich in carbon. They may be the last remnants of small moons that were disrupted by gravity and pulverized into tiny fragments. The rings are just one element in a story that suggests this quiet and dark outer region of the solar system was once witness to scenes of great violence. Uranus, for example, is nearly tilted on its side. Instead of spinning like a top, it rolls like a bowling ball, first pointing one pole and then the other almost directly at the sun. Its rings and moons are oriented the same way, giving Uranus the appearance of a giant bullseye in space. This peculiar tilt was almost certainly the result of a giant collision long ago in the planet's history, perhaps near the time it was forming. Other signs of past collisions can be found on Uranus's bizarre icy moon, Miranda, which looks like it's been blasted apart and put together again the wrong way. Its craggy cliffs are among the highest in the solar system. Meanwhile, Neptune's largest moon, Triton, orbits Neptune backwards. How this happened is not easily explained, but it is likely Triton did not begin as a moon of Neptune. As Voyager 2 discovered, Triton is only slightly smaller than our own moon and larger than Pluto. It may have once been an independent citizen of the outer solar system that wandered too close to Neptune and was captured, perhaps after colliding with some of Neptune's other moons. Today, Triton's icy surface is crisscrossed with markings that hint at a geologically active past. The surface is made of ice, frozen water, but it's cold enough to be as hard as rock and has a strange texture resembling the skin of a cantaloupe. Much of its southern hemisphere, the only part seen by Voyager, is covered with a methane and nitrogen frost. Dark streaks on the ice are probably the sooty residue from gas geysers breaking through the icy surface. The streaks are parallel, suggesting that winds blow fast in Triton's thin atmosphere. If Triton was captured by Neptune, then it is our first opportunity to see up close an entirely new class of objects. These are small, icy, and moon-like bodies that escaped becoming part of a larger planet when the solar system formed. Now, they silently patrol the vast border region of the solar system, starting just beyond the orbit of Neptune and extending far into the deep space beyond, where the distant sun is no more than a bright star. Pluto and its moon Charon are surely members of the same family. When it was first discovered, Pluto was hailed as the 9th planet. But its tiny size and unusual orbit suggest it is not exactly a planet, but something else. In recent years, many more objects have been spotted at a similar distance, including Eris, found in 2003. Eris is even larger than Pluto. Rather than making it the 10th planet and potentially adding many more to the list, astronomers demoted Pluto instead. Now Pluto and Eris are grouped with similar objects in a newly created category, dwarf planet. The region where Pluto, Eris, and other dwarf planets live is known as the Kuiper Belt. As many as 70,000 separate objects larger than 100 kilometers may ultimately be found here. And they are clearly not all alike. For example, the Kuiper Belt object known as Sedna is redder than Mars. Its color may be due to chemical changes that occurred during billions of years of cosmic rays striking organic molecules trapped in Sedna's icy surface. Sedna's orbit stretches out far beyond the Kuiper Belt, suggesting other hidden members of the solar system may still be lurking just out of sight. Tiny and remote, the inhabitants of the Kuiper Belt appear as little more than dots, even in the world's most powerful telescopes. Yet these objects are among the most interesting to scientists because they can tell us a story about the early days of our solar system when the giant planets were still forming out of icy building blocks like these. In 2006, to satisfy our curiosity about these most distant members of the planetary family, NASA launched New Horizons. No spacecraft has ever traveled so far to meet its primary objective, and the journey has only just begun. Now, New Horizons is well on its way to the outer limits and is scheduled to reach Pluto in 2015. When it arrives, it will be moving too fast to be captured in orbit. Instead, it will fly past both Pluto and Charon, radioing back images and data, and showing us for the first time what a dwarf planet is really like. At its closest, New Horizons will see details as small as 50 meters across on Pluto's icy surface and look for signs of past geologic activity. After Pluto, New Horizons will move on to other targets in the Kuiper Belt, including some which may not have even been discovered yet. If it succeeds, scientists hope the most distant and mysterious region of our solar system will finally seem a little more familiar. When New Horizons finally shows us Pluto, it will mark the end of an era. Pluto is no longer officially called a planet, but it represents the last type of solar system object that we have yet to see up close. Without Pluto, our story of the solar system and its history is missing an important chapter. New Horizons will write that chapter, and for the first time, give us a glimpse of the entire book. The whole solar system in all its diversity, from the blazing sun to the dark depths of the Kuiper Belt. Somewhere in that book is the story not just of rock, gas, and ice, but the story of chemical complexity and life itself. There are more than 100 moons in our solar system. The vast majority of them orbit the two largest planets, Jupiter and Saturn. Collectively, they run the gamut from small to large. cold to hot, and quiet to active. Could it be that somewhere in that range of possibilities, we will find a hidden haven for alien life? Most of the moons that orbit Jupiter and Saturn are quite small, but a few are so large and complex they could easily be considered planets. For more than 300 years, there was almost nothing astronomers could say about these intriguing places. Thanks to spaceflight, that's no longer the case. In 1979, Voyager 1 and Voyager 2 sailed past Jupiter's 4 largest moons, with their cameras rolling. The pictures they radioed back reveal that each moon has its own distinct character and a range of features unlike anything seen before. The biggest surprise of all was Io, the innermost of the 4 moons. Its rocky surface is a mottled and sulfurous mess. Unlike our moon, there are no craters on Io. It's as though they are being erased by some mysterious agent. The explanation came when Voyager 1 spied something unusual protruding 300 kilometers from one side of Io. It was a fountain of ash spewing from a large volcano. Since that discovery, it's now become clear Io is the most geologically active world in the solar system. Io's surface is one vast lava flow, with more than a dozen active volcanoes towering over the sulfur-rich landscape. The gravitational pull of Jupiter and some of its other large moons creates a tug-of-war inside Io, which generates vast amounts of heat. While this makes for a dynamic surface, it is not particularly hospitable to life. Jupiter's outermost large moon, Callisto, couldn't be more different. Callisto's battered face is saturated with ancient impact craters, suggesting not much has happened here since Callisto formed. But looks can be deceiving. The most recent data suggest there could be a zone of salty water somewhere deep below Callisto's surface of ice and rock. Whether life could survive in such a hidden environment remains an open question. Meanwhile, on Ganymede, we find more obvious signs of a geologically active past. Ganymede is the largest moon in our solar system and one of the strangest looking. Part of its surface is as old as Callisto's, dark and heavily cratered. But the dark areas are fractured by a more recent terrain made up of parallel grooves and ridges. Exactly how these grooves and ridges formed is still a big mystery. It is clear Ganymede has a warmer interior than Callisto. In the past, that warmth may have risen up through Ganymede's interior and forced sections of its surface to drift apart, just like the continents on Earth. Because of its heat, Ganymede's interior has likely separated into layers, starting with an iron-rich core at the center, a surrounding mantle of rock, and a thick layer of ice on top of that. As with Callisto, there is evidence on Ganymede for an ocean of salt water somewhere below the surface. This is exciting news because the right combination of heat and water may provide the conditions necessary for life on Ganymede. Such life forms would be cut off from the sun and the surface environment. But like the creatures that live around deep sea vents in Earth's oceans, it might survive on chemical energy. This tantalizing possibility won't be tested anytime soon. If Ganymede has an ocean, it's at least 200 kilometers below its frozen surface. A better opportunity for exploring the ocean of another world may exist on Europa. At first glance, Europa seems like the least interesting of Jupiter's moons because its surface is so flat and smooth. Its lack of dramatic relief, like mountains or large craters, might be an indication that water isn't far below. Europa is crisscrossed with a network of cracks that suggest its icy crust has opened up from time to time, letting a watery slush spill out onto the surface. In one area, scientists have found what appear to be icebergs that cracked and floated apart like rafts before the surface refroze. Some of the cracks on Europa have a darker and more reddish hue than the rest of the surface ice. This could mean that the underlying ocean is rich in sulfur compounds and perhaps organic molecules. Indications are that in some places, this ocean may be less than 10 kilometers from the surface, possibly within reach of a future attempt to drill down and explore the marine environment of another world. Today, Europa's ocean is high on the list of locations where scientists are eager to search for alien life. The surfaces of Jupiter's moons may conceal many mysteries. But on Saturn's giant moon, Titan, even the surface is hidden from view. Titan is the only moon in our solar system with a substantial atmosphere, and it shows. When Voyager 1 arrived at Saturn in 1980, it found Titan shrouded by a thick orange haze. This haze is like a photochemical smog produced when sunlight reacts with methane in Titan's atmosphere. It would be a full generation before scientists had their next chance at Titan. When the Cassini mission arrived at Saturn in 2004, it used a high-powered camera equipped with an infrared filter to penetrate the veil of Titan's thick haze. What Cassini found was even stranger than expected, a surface divided into mysterious light and dark regions, resembling ancient coastlines. Cassini also bounced radar signals off of Titan, confirming that the moon's surface is solid, with unusual landforms like ice volcanoes and wind-blown dunes. A series of dark patches that were perfectly flat, resembling the surfaces of small lakes. Scientists were eager for more direct evidence of potential fluid flow on Titan. They found it in dramatic fashion when Cassini dropped a probe into Titan's cloudy atmosphere. After the probe deployed its parachute and slowly descended, it radioed pictures back to Cassini. As soon as the probe emerged from the clouds, it began to see exciting details that looked suspiciously like they had been carved by a flowing liquid. Then, to everyone's surprise, the probe survived its impact and sent back one final spectacular image. It showed chunks of ice, clearly rounded by fluid flow, like rocks in a stream bed on Earth. On Titan, it's so cold that water is like rock, but methane, which is a gas here on Earth, can rain down from Titan's atmosphere and flow as a liquid over the surface. Methane is a building block for the kinds of complex molecules that led to the emergence of life on Earth. And that means if Titan has an internal heat source, like some of Jupiter's moons, it could also be harboring its own ecosystem deep below the surface. One thing is clear, Titan and Jupiter's moons are no longer sideshows to the planets they orbit. Together, they have become the main motivators in our exploration of the outer solar system. Here on planet Earth, it's easy to take water for granted. Water covers 70% of Earth's surface, and its presence is essential for life as we know it. Farther away, in the dim reaches of the outer solar system, water plays a different role. Around Saturn, water is everywhere. With temperatures near minus 180 degrees Celsius, it's far too cold for water to exist in a liquid state. Here, water remains frozen solid, so solid that it doesn't just cover worlds, it makes worlds. When we get to Saturn, we discover ice is the main ingredient in building moons. In fact, Saturn is surrounded by an entire family of icy moons that the Cassini mission has now revealed in spectacular detail. By exploring these frozen worlds, scientists hope to reveal an ancient story, not just about Saturn, but about the entire outer solar system. This is certainly the case with Phoebe, the first of Saturn's moons that Cassini encountered up close. Just 200 kilometers across, Phoebe is too small and its gravity too weak to pull itself into a sphere. When Cassini sailed past Phoebe, it found a surface rich in carbon, with deep craters exposing layers of bright white ice lying just below. Overall, Phoebe is darker and contains more rock than Saturn's other icy moons. This suggests it did not form near Saturn, but in the Kuiper Belt, beyond Neptune. The objects inhabiting this zone are ancient, the original building blocks of the outer solar system. It now appears Phoebe is an escapee from that region and only later captured by Saturn and turned into a moon. This moon is giving us a sneak preview of what we'll find at much further distances from the Sun. 4 times closer to Saturn and 4 times larger than Phoebe, Iapetus is a very different kind of moon. It is 80% ice, but its most distinctive feature is its strange two-tone shading. While one side of Iapetus is extremely dark, the other is whitish gray. This color difference also corresponds to a significant temperature difference. On average, the dark side is 15 degrees warmer than the light side. I suspect that dark material, possibly blasted from the surface of Phoebe, may have fallen down onto Iapetus long ago. The side that received the dust absorbed more of the sun's energy, and the ice there began to sublimate, leaving behind grains of dust and rock that would darken the surface even further. Meanwhile, the vaporized ice resettled onto the other side of Iapetus and around its poles, creating the look it has today. Even stranger is a long ridge Cassini discovered running along the equator of Iapetus, giving it the appearance of a walnut. In places, the ridge is 13 kilometers high. The forces that created this bizarre feature are not well understood, but it likely happened when Iapetus was spinning more rapidly than it is now and had more internal heat shaping its surface. Moving even closer towards Saturn, we find Hyperion, a misshapen object with a strange honeycombed surface. Hyperion is so irregular in shape and appearance, it is probably just a fragment from a larger moon that was destroyed in a collision. It may not even be solid, but a loosely packed pile of rubble. Measurements by Cassini reveal Hyperion is more than 40% empty space. Signs of ancient collisions are visible everywhere on Saturn's moons, including Rhea, Dione, and Tethys. At first glance, this trio of round moons could be mistaken for identical triplets. Each one is more than 1,000 kilometers across and carpeted with impact craters from billions of years ago. But they are also variations on a theme. Each of the three has its own distinct features, suggesting a more complex and diverse history. For example, this giant canyon called Ithaca Chasma wraps around Tethys like a waistband. It may have formed long ago when the icy interior of Tethys froze and expanded, forcing its crust to stretch apart at the seams. Looking at Dione from afar, scientists long wondered about a series of wispy white lines running across its surface. Now Cassini has revealed the lines are the bright faces of steep cliffs formed when Dione was repeatedly fractured by internal forces. But the biggest surprise came from Rhea. Cassini found indirect evidence this moon is surrounded by a dark, dusty ring, making Rhea the only moon anywhere in the solar system with a ring of its own. While most of Saturn's icy moons were likely once geologically active worlds, which later cooled and grew dormant, at least one seems to have forgotten to fall asleep, and the implications are enormous. Enceladus is only 500 kilometers across. Under ordinary circumstances, an object of this size should be too small to retain heat for billions of years. But Enceladus is nowhere near ordinary. Here, Cassini spotted vast geysers of water vapor shooting outward from a region near its south pole. The vapor carries fine grains of dust, which escape into space and form a diffuse ring along Enceladus's orbital path around Saturn. Looking down at the surface for clues, Cassini has revealed a strange and puzzling sight. Enceladus is scored with long, deep gouges, nicknamed tiger stripes, from which the geysers are thought to emanate. The stripes are surrounded by fresh ice, which suggests that somewhere below the surface, temperatures are high enough to melt ice and hold liquid water under pressure before venting it into space like a tea kettle. No one yet knows exactly how Enceladus does this. One important clue from Cassini is that Enceladus has more rock and metal than many other of Saturn's moons, and so perhaps it is being warmed by a combination of radioactive heating from within and strong tides produced by Saturn and its other moons. Even more exciting is the presence of organic molecules near the tiger stripes. When this is combined with the likelihood of liquid water, it appears Enceladus may have all the ingredients necessary for life. For a tiny moon at the leading edge of the icy solar system, this is an astonishing revelation. To call the icy moons of Saturn strange is an understatement. These odd little worlds are utterly unlike Earth. But understanding how they formed and evolved is an important goal for scientists. Why? Because if there are so many icy moons in our solar system, there must be countless others out there among the stars. Whenever one of those moons is warmed up enough to melt the ice into water, the star's dazzling colors offer a clue to their history. As expected, most are yellow or red, indicating these stars are entering their old age after shining for billions of years. But the blue stars, which are much hotter, seem a mystery because blue stars should be very young. Astronomers now suspect some of these blue stars are the result of stellar collisions and mergers. The amazing clarity with which Hubble can view these stars also gives astronomers a window into the future. By comparing this image with earlier images of Omega Centauri, Hubble can see that the stars have moved. And by extrapolating those motions, astronomers can simulate a 10,000-year timeline, showing how the stars will migrate as each What Hubble found is that at these great distances, galaxies tend to be smaller and more distorted in shape. This tantalizing result means that Hubble is beginning to see back to an era when the galaxies were still forming, mere adolescents on their way to becoming the grand star systems we see today.